Morning, everybody. Today's the 14th of April, and here's today's math lesson. We're going to be looking at 8.3, which is creating and evaluating expressions. So our learning goal for today is to be able to read a sentence, turn it into an algebraic expression, and then solve it. All right? So here is our sentence. Patrick eats 3 bananas a day. There are his 3 bananas. And so I've read my sentence. I need to turn that into an algebraic expression. So 3 bananas times each day, or 3 times D equals B. D will be for the day, and B will be for banana. So 3 times however many days it is will give me how many bananas this guy eats. How many bananas is that by day 7? So I have my algebraic expression, 3 times D. I know what D equals. In this case, D is 7. So I take out the D. I put in the 7 for 7 days. Now it's just 3 times 7. That means 21 bananas. It's a lot of potassium. But what if I have different information? What if I know how many bananas he eats, but I have to figure out what day that happens on? Well, I still use my algebraic expression, 3 times D equals B. But in this case, I don't know what D is, but I know what B is. B is 36 because he's eating 36 bananas. Well, now I'm basically asking myself, what number times 3 gives me 36? Well, I can rewrite that sentence. I can rewrite 3 times D equals 36, so it looks like D equals 36 divided by 3. Now it's just simple division, so D equals 12. And because it's a word problem, I need my sentence at the end. On day 12, Patrick will eat 36 bananas. I don't know why there's a question mark there. That shouldn't be there, so disregard the question mark. All right? So I've read my sentence, created my algebraic expression, and I've used it to solve. All right. Maybe I meant for an exclamation mark. I'm not sure. All right? Now, what if we have a chart? All right? Something like this. Here is my chart, and I need to find out what the algebraic expression is. So my first term is 4, my second term is 9, my third term is 14, and my fourth term is 19. I need to come up with my algebraic expression, because once I have my algebraic expression, I can solve for the 10th term, and I can solve for the 15th term. So going across the chart from 1 to 4, 2 to 9, 3 to 14, 4 to 19, there could be a number that we just have to add. Let's see. Let's do a little brainstorming to see if we can figure that out. Well, 1 to 4, I could just add 3. 1 plus 3 is 4, but then 2 plus 3 does not equal 9. So the answer is not term plus 3. That doesn't work. I could do times 4. 1 times 4 is 4, but it has to work for the next row as well. 2 times 4 is 8, and the answer is 9. So it's not times 4. Looks like it's going to be more of a complicated one. So in that case, because we can't seem to figure out the pattern going across the chart, let's look at the common difference going down the term numbers. 4 to 9, 9 to 14, 14 to 19. Well, we can see that those numbers are increasing. They're getting bigger. And now we just need to make sure we know what they're increasing by. Well, 4 to 9, that's plus 5. 9 to 14, plus 5. 14 to 19, plus 5. Remember, this plus 5 becomes very valuable because the plus 5 over here actually means times 5 over here. It tells us that we need to do some multiplication as part of our algebraic expression. So let's go back. 1 times 5. So we know it's all going to be term number times 5. So we're going to add that in. And I'm going to go t times 5. But 1 times 5 is 5, but our answer is 4. So how do I get from 5 to 4? Well, I have to subtract 1. 1 times 5 is 5. 5 take away 1 is 4. let's make sure the rule works. 2 times 5 is 10. Take away 1 is 9. 3 times 5, take away 1 is 14. 3 times 5 is 15. Take away 1 is 14. 4 times 5 is 20. Take away 1 is 19, which means our algebraic expression is t for term number. And again, or for term, you can use any letter you want. I'm just using t. T times 5, take away 1. That's our algebraic expression. So let's use this algebraic expression to solve for this. So what is it for our 10th term? Well, if we know that t is for 10, or sorry, if t is for term, we just need to take out the t and put in a 10. So I'm going to rewrite my algebraic expression. T times 5, take away 1. I'm going to put in a 10. 10 times 5, take away 1. I'm just going to move my chart paper here. So I have 2 operations to do. I have 10 times 5, and I have 5 take away 1. Order of operations tells me I do multiplication before I do subtraction. So 10 times 5, that's 50. Take away 1 equals 49. So the 10th term in this pattern is going to be 49. What if I wanted to find out the 15th term? Well, let me write my algebraic expression. Times 5, take away 1. T stands for term. And in this case, the t is going to be replaced by the 15. So 15, take away 5. Sorry, 15 times 5, take away 1. Order of operations tells me I have to do multiplication before I do subtraction. So 15 times 5, what would that be? Well, 15 times 4 is 60. So if I add another 15 to that, it would be 75. 75, take away 1, which is 74. Okay? All right, let's look at a bigger word problem. Bear with me while I flip the chart paper here. That's written. Oh, jeez. Okay, let's take a look at this. So, we got. Let's see what it says here. Mr. De La Rosa plans a trip for all the 6, 7, and 8 classes to Ottawa. He's going to need 7 buses for those 260 kids. He has 3 bus options. So because we have a word problem, I'm going to make sure to identify the numbers and math words that probably are going to be important. So let me grab my marker. I see 260 kids. I see 7 buses. I see 3 bus options. There's also the grades 6, 7, and 8, but in this case here, they're numbers that just describe the classes. There's a grade 6 class, a grade 7 class, and a grade 8 class. So we're not actually going to use them for anything. So I have 3 bus options. Carry All Bus Company charges $350 per bus. And I can write that as an algebraic expression, 350 times B. Why times B? B is for bus. And remember, the word per just means each. $350 each bus. So there's our algebraic expression for the first one. Next company, Kids First Bus Company, charges $7 per kid. And remember, per just means each. Now, in this case, I change my algebraic expression to $7 times K. Why times K? Well, I figured K for kid. You can use any letter you want as long as you remember what the letter represents. The variable can be anything. The third company called Big Bus Company charges $500 plus $6 per kid. So in this case, there's my $500 plus the $6 per kid times K. Remember, per just means each. So what's the best option? These are my 3 choices. Which one should Mr. De La Rosa go with to plan our bus trip? course, this isn't imagination land when we can still go on trips, but that's all we have right now. So let's look at the first option, carry all. So carry all, this was our algebraic expression, $350 times B. And B is the number of buses. If you remember back in the word problem, we need 7 buses. So all I did was take out the B, put in the number 7. $350 times 7 buses gives me $2,450. All right. Right off the bat, that seems like a lot of money, almost $2,500. So I don't think the first option is going to be correct. Let's look at option number 2. Kids First charge $7 a kid. We have 260 kids. So we go back to our algebraic expression. We take out the K and we put in 260. Why 260? Because that's how many kids there are. Notice it's still $7. The $7 doesn't change. That's the constant. It's always going to be there. So 7 times 260 gives us $1,820. Already a lot cheaper than option A, which means option B is looking pretty good, but let's work with option C. Let's solve option C just to be sure. So the big bus company charges $500 plus $6 per kid, or 6 times K. So the $500 is the constant. It's always there. The $500 is just there. All right. Maybe it's the deposit that the school has to pay for the bus. You just have to pay it anyways. And the $6 is also a constant because it's the 6 times kid. And we knew from the second option that there's 260 kids. So order of operations tells me I have 2 operations. I have 500 plus 6, and I also have 6 times 260. Which one do I have to do first? Order of operations tells me I have to do multiplication first. Multiplication has to happen first. So I do that first. 6 times 260 is $1,560. And my $500 is still there. I haven't done anything to it. I haven't touched it yet. Now, I just simply add those 2 numbers together, which gives me a grand total of $2,060. So the 3 totals that Mr. De La Rosa has to work with: $2,450, $1,820, and finally $2,060. So because it's a word problem, we need a sentence. Mr. De La Rosa should pick Kids First. Okay? And that's basically it. We read a sentence, we figured out our algebraic expressions, and then we solved it. We've met our learning goal for today. So watch the video as many times as you need to. Pause, take notes, put questions in the comment section, and I will do my best to answer them. And I will post the homework to go along with this after the video goes up. Take care, everybody. Bye-bye.